Hello and welcome to Maths with Jacob. This lesson will focus on Factorising Part 2. This video is a continuation of the earlier lesson we had on factorisation. In this lesson we will also show how to factorise different examples relating to the difference of two squares. Let's look at some simple examples first. Factorise each of the following. So for number 1 we have to factorise 4m minus 8. If we remember, we need to find the HCF in order to carry out the task. The HCF is 4. So here the HCF is the highest number that divides both into 4m and into 8. Hence 4m minus 8 equals 4 outside of m minus 2. And that's the factorisation. 10w plus 15. That's 10w plus 15. The HCF is 5, because 5 is the highest number that divides into both of those terms. Hence 10w plus 15 equals 5 outside of 2w plus 3. And that's the factorisation. And if you expand all that, that gives you that expression there. The next one, factorising the difference of two squares. So, factorising the difference of two squares is the reverse operation of expanding the product of a sum and difference. Let's look at what we mean here. So this is the product of a sum and difference, and when we expand it, we end up with m squared minus k squared. We saw that in an earlier video, so that's called the expansion. For factorisation, that's actually the opposite or the reverse operation. So if we start off with m squared minus k squared and we are asked to factorise it, we end up with m plus k, m minus k. So that's the factorisation part. Let's look at some specific examples on the next slide. Now here are our particular examples. Factorise each of the following. Check if there is a HCF first. So we're asked to factorise k squared minus w squared. There is no HCF, excuse me, because there's no term that divides into those two. So k squared minus w squared will be k plus w, k minus w. M squared minus 16, there's no HCF, so m squared minus 16 is actually m squared minus 4 squared, which is m plus 4, m minus 4. So that's the factorisation. For number 3, 7h squared minus 28, the HCF is 7, because 7 is the highest number that divides into both of those terms. So 7h squared minus 28 is 7 outside of h squared minus 4, which is 7 outside of h squared minus 2 squared, which is 7 outside of h plus 2, h minus 2. So that's the factorisation. And in that example, there was a HCF. And the last one, 18y squared minus 50z squared, the HCF is 2, so that expression could be expressed that way, using the grouping symbols with a HCF outside. 9y squared can be written like that, 25z squared can be written like that. So, because that's the difference of two squares, the final answer will be the 2, which is the HCF, and here we have the product of the sum and difference. So that is actually the factorisation. So this video has looked at the second part of factorisation, where we have to look closely to see if there's a HCF before we attempt our factorisation. And if there is, we take the HCF outside of the brackets, and then we proceed from there. And we always have to look very closely to see the type of factorisation that we have to do.